Section 1.1.3, Solving Linear Equations in One Variable, is a vitally important section. It's probably review for you, but it's going to be fundamental for all of the equations that we'll be solving this semester. So it's really important that you work to master solving linear equations in one variable. So to begin with, a linear equation in one variable can be written in the form ax plus b equals 0, where a and b are real numbers and a is not equal to 0. So what that means, a and b are numbers and x is the variable. To solve a linear equation means to figure out the value of the variable that makes the equation true. What we have here is the steps to solving a linear equation, also known as an algorithm. An algorithm is just a process or a set of steps that we follow in order to solve the problem. So step 1, we want to clear fractions by multiplying each term by the LCD if necessary, and we'll do an example to show you how to do that. Number 2, remove parentheses using the distributive property. Number 3, combine like terms on each side. Number 4, we're going to start separating variables on one side and constants on the other. 5, divide both sides by the coefficient of the variable. And finally, check by substitution. This is a really important step, and you can use your calculator to assist in that. In a nutshell, when we solve a linear equation in one variable, our goal is to isolate the variable. And that algorithm shows you the specific steps to do in order to isolate the variable. So let's try example 6. We're going to solve this linear equation. It's not in that standard form that matches the definition, but what I want you to understand is that because x is raised to the power of 1, and there's no x squared, there's no x cubed, there's no square root of x, this makes it a linear equation. So if the highest power of x that I can find is 1, it is a linear equation. So to solve this, first of all, we're going to recognize there's no fractions that we need to clear, but we do need to clear some grouping symbols. So we're going to use the distributive property here to break up those grouping symbols. We have 3 times 4x, which is 12x, minus 3 times 2, which gives us minus 6. Then I'm just going to copy down the other terms and clean house a bit. I'm going to combine like terms on both sides, and all we have here on the left is a couple of constants to combine. Negative 6 plus 1 gives us negative 5. Now my goal is to collect the variable terms on one side, preferably the left, and the constant terms on the right side. So if I move my variables to the left, then this guy has to go. We're going to subtract 2x from both sides so that 2x minus 2x cancels out, and combining like terms on the left side here, 12x minus 2x gives me 10x. Okay, and all we have left over there on the right side is 5. Now I want to move my constants to the right. So I'm going to add 5 to both sides so that I can get it to cancel on the left. Then all my constants will live on the right. So we have 10x equals 10. Finally, we're going to divide both sides by the variable's coefficient. We're going to divide by 10 on both sides, so that cancels out and gives us a coefficient of 1, which we don't have to write down. And on the right side, 10 divided by 10 is 1. So the solution to this equation is x equals 1. Now, to check this equation, we're going to plug 1 in for x. So up here, I'm going to go back to the original equation, and I'm going to plug 1 in for x on both sides. And I'm going to check to see if that's a balanced equation. So following the order of operations that we've reviewed, inside parentheses here we have 4 times 1, which is 4, and 4 minus 2, which is 2. Now at this point, I don't really want to move anything from one side to the other. I just want to evaluate both sides according to the order of operation and make sure that I get a balanced equation. So notice we do get 7. 7 equals 7. So that shows that we have a balanced equation when x is equal to 1. So the solution to the equation is x equals 1. This just shows me that 1 causes the equation to be balanced. In the next example, we do have fractions. So our goal is to clear the fractions using the lowest common denominator. So between 2 and 5, the lowest common denominator is 10. Now, I'm not actually going to be getting common denominators. I'm going to be canceling denominators. So this is a technique that we'll use quite a bit during this class. I'm going to multiply each term by 10, or I can think of it as 10 over 1. So all 3 of those terms are going to get multiplied by 10 over 1. I'm going to put the original terms in blue and show that they're each getting multiplied by this new number 10. Since that 6 is not a fraction, I'm going to write 10 as a plain old 10 instead of 10 over 1. So what you see is all of the original terms of the equation are written in blue, and you can see every single term has been multiplied by 10. Next, I'm going to go through and cancel like factors where I can. So looking at this product, 2 divided by 2 is 1, and 10 divided by 2 is 5. Also, we can reduce this one a bit. 5 divided by 5 is 1, and 10 divided by 5 is 2. Let's see what's left. 5 times x gives us 5x. 10 times 6 is 60, and we have 2x left over here. So by multiplying each term by the lowest common denominator, we were able to clear the fractions and then make our equation a little easier to solve. Next, I'm going to collect variable terms on the left. We can do this by subtracting 2x from both sides. That's going to leave behind 3x plus 60 and a 0 over here on the right. And then we can subtract 60 from both sides to get all of our constant terms over there on the right side. And then to finish, we'll divide both sides by the coefficient of x, which is 3. And we end up with x equals negative 20. Okay, I also wanted to mention that you can check these just as easily with your calculator as jotting it down with pencil and paper. So I'm going to go back to the original equation, and everywhere I see an x, I'm going to replace it with negative 20. So let's see what we end up with on the left side. Plugging negative 20 in for x, we have negative 20 divided by 2 plus 6. So the value on the left side is negative 4, and let's check the right side. So now I'm going to plug negative 20 in for x on the right side, and notice that also gives us negative 4. That tells us that the left and the right side have the same value, so we have a balanced equation, which means negative 20 is the correct answer. The next example also has fractions. It's a little more complicated, and so using this technique of multiplying by the LCD will really simplify this equation. So let's first discover what our LCD is. The LCD is 12, lowest common denominator. So I'm going to multiply all 3 of those terms by 12 over 1. I'm going to multiply the 3 just by an ordinary 12, since it's not a fraction. And then once everything has been multiplied by the LCD, we're going to go back and cancel like factors where we can. 4 divided by 4 is 1. 12 divided by 4 is 3. And then over here on the end, the 12s cancel, leaving behind a 1. Now, we are going to have to be careful with our multiplication. What we have left here is 3 times x minus 8. However, this is not written correctly. We need to multiply both terms by 3, which means we have to have a set of parentheses around that x minus 8. That's easy to forget, so please watch for that. The same thing is going to be true on this product. We have minus 1 times the double term, or the binomial, x plus 2. So please remember those parentheses whenever you have a binomial in the numerator. So I really want to emphasize those are absolutely necessary. Next, we can break up those parentheses with the distributive property. So 3 times x is 3x. 3 times negative 8 is negative 24. And on the right side, we need to distribute the negative 1. Negative 1 times x is negative x, and negative 1 times 2 is negative 2. Now, on the right side, before we start moving things from the left to the right, let's combine like terms. 36 minus 2 gives us 34. And now we can start collecting variable terms on the left. I'm going to add x to both sides. And that's going to leave behind 3x plus x, or 4x minus 24, and 34 on the right side. And let's get our constants on the right. We can do that by adding 24 to both sides. We know to choose each operation using opposite or inverse operations, right? Because 24 was subtracted on the left. I add it to both sides, and that causes it to cancel out. Here, x is multiplied by 4, so I'm going to do the opposite and divide both sides by 4, and that will isolate x. Notice here, 58 divided by 4, both of those numbers are even numbers, so let's go ahead and reduce by a factor of 2. 4 divided by 2 is 2, and 58 divided by 2 is 29. So it looks like we end up with a fraction for our answer, 29 over 2. That's one we definitely want to check with our calculator. So everywhere we see an x in the problem, we're going to replace it with 29 over 2. And also notice, because we have an operation in the numerator of the fraction, we're going to need a set of parentheses here and a set of parentheses here. So let's go ahead and plug 29 over 2 in for x on the left side only. So we have parentheses 29 over 2 minus 8, close parentheses, divided by 4. It's going to give me a decimal value, and that's fine. Just want to check and make sure the right side gives me the same decimal value. So typing in the right side and getting that numerator in parentheses, we're replacing x with 29 over 2, and it yields the same decimal. So that gives us confidence that we have a balanced equation when x equals 29 over 2. So x equals 29 over 2 is the correct answer.